Hello, hello. Going on to, this is my first one for the collaborative setting contest thingamajiggy. Rather like the look of this one because it was based on a flock of pixels. Though so far I haven't seen a huge strong relationship. Obviously you got some cages and the such. And then also, I can't remember what it's called, but I just solved it before this to get into some puzzle solving. But anyway, drawing a normal loop that acts as a German whispering can actually touch itself diagonally in this case. Digits can't repeat in cages, but the actual sum is only to do with what is on the loop. Digits? So what, are they all on the loop? How does that work? "27. Number in the cage indicates the total sum of cells that the loop passes through. Oh, within the cages of... okay. Right. Well, I see where the flock of pixels thing comes in now. Interesting. Yeah, I totally misread that rule, first of all. Oh, this is a harder puzzle than I thought it was going to be. A digit in the circle indicates the total number of cells that the loop passes through within cages orthogonal again. Okay. Right. Interesting. Ha. That's been a bit of a curveball. So, I mean, could these take 3 cells each? Yeah, potentially. So that could be as much as 8. Taking 3 and 3 and 1 and 1. Right. And I know that the sum of loop cells in these has to be 6. So what on earth does that imply? I think that's got to be where you start, because that does restrict things quite a bit. Because you can never take 2 cells, can you? Because then that sums to at least 7. And that's exactly true for all of that. So, for example, you can never take this cell, because that would imply you're taking 2 cells within pink. And that's the same for anything that's covered on 3 sides. Like all the Tetris piece looking things. Oh, and also that one, because it touches the edge. So, if you... yeah, and you can't take that, because you're not allowed to go in here. So if you did come in here... because it's only to do with orthogonal stuff, isn't it? Let's... if you take none of this... and obviously... you couldn't take any of that. Take any of this. Take that cell or this cell. Or any of this or any of that. But that, I think, is okay. Well, obviously you've got to take... and you know you've got to take some... yeah, so let's say you didn't go in 6. If you don't go in 6, then you're not going to take any of this, any of this, any of this, any of this, any of that. The problem is this circle in this cage implies that you need to take at least 1 cell out of all this. So we definitely go inside 6. And therefore, the loop is going to come through here, and then it's going to come out again to... so these are the same colour. And again, you can only go through things that are the same colour, can't you? in terms of checkerboarding the whole grid for high lowness of the German whisper. So if you come in here, you've got to come out there. And of course, they're both low. And of course, they're both threes. Aren't they? Yeah. That's pretty crazy. That's interesting as well. So if you do that and these are threes, that just instantly breaks. Cool, cool, cool. We've got these 2 threes to start us off. Bunch of 8 9s. Nice. And this is now all loop. This is now all loop. I'm going to get rid of that for the moment. I normally do pink as not loop, so I'll stick with that. None of this can be loop, obviously. This cell can't be loop. Nice. None of this stuff is loop. So and now we can't go in any of this either, can we? Obviously, because you've got your... Oh, no, hang on. I'm not sure about my 2 3s anymore. Because you could be... Yeah, you could be obviously just smaller and then you take one of these. Whoops. So even in this case, because that is a maximum of 3, that does still break. So we definitely are coming through like this. And they're both 1 2 3. But I think that this stuff I wanted to do, let's get rid of pink. Change that to that. Because you could go into there. You obviously can't go into there. That's because that's a high digit. Similarly there, that's a high digit. But you could, in fact, if you wanted to go wild, take all of those. Which is pretty mental. Pink all of that, though. And now this takes 3, 4, 5, 6, or 7. Oopsie daisy. Let's get rid of 6 from here. Because we've got 3 in here, 4, and then you're either taking 2 or 3 from that. One. Oh, golly, excuse me. One way or the other. Good. Right. Now, that circle looks interesting because it's at least 1 and at most 3, so it's actually pink. That can't, because it would have to be high otherwise. And if that was 1, then both of those would be pink. Seems okay. I was wondering if you are allowed to come around like this. I'll put you 6 of the 2 1s. Make you have to do that as well. I think you... No, because 4s. Yeah. So we definitely don't come round at all. But you still don't have to take either of those, which is interesting. I know that the sum... I know something about the sum of all these, so you have to take at least one of them. And if you didn't take that one, yeah, you have to take that one, of course, because then you can't take that one. So either that's a 3. You do take this cell. And what else does that mean? Get rid of these 3s, by the way. That's a 3. What am I trying to say? Those could be a pair of 1s with a 7 or a 1 2 and a 6. That would always be 1, wouldn't it, in that case? And of course, yeah, that couldn't be 6. That would be 7 with a pair of 1s. Which is interesting because it makes that cell green. Which is probably fine, isn't it? Interesting. I thought this was going to be a straightforward loop puzzle. One. So taking 3. You could have quite a lot, couldn't you? You take both of those. Then you could probably take 3 of these. 3, 4, 5, 6, 7, 8, yeah. If you don't take things like that, how about this circle? This circle should be interesting because it's either could be as small as 1, but it's at most 3. That's if all of those are green. I was just wondering about if we could say anything about what colour that was. That's 3. That could be a 4 with a pair of 9s, I suppose, couldn't it? Interesting. This cell's pink. Oops. Alrighty. Circle this circle. So if this did come like that, that would be a 2. And then those just sum to 9, so that's fine. Maybe to do with these 9, this 9 clue here, maybe? Because, yeah, you can't take that cell, can you? No, that's small. You can't take that cell or this cell, because they're both small. Now, what does that imply? Are we allowed to go down and round? Probably. But possibly not, actually. Yeah, if you... Well, you know you have to take one of these, because that doesn't sum to 9. If you took both of them, that's just stupid, isn't it? Yeah. So you take exactly one of these two. If you take that one and you look like this, you come across like that. And then all that does imply that those 2 cells are the same. In fact, yeah, all this is doing is implying that either those 2 are the same or those 2 are the same. So it could turn in if it really wanted to. Is there anything wrong with this, though? In terms of the German Whisper, I'm wondering. And you could... Yeah, you could still take that if you wanted. I've said that if you do take that, right? I've said that would have to be a 1. Meaning that's not 6, but... that doesn't help so much. Things not repeating, is that useful? Will be at some point, won't it? If this doesn't take that cell, it comes up around. Obviously couldn't take this anymore. I think it could still take that. Or just leave at that point. No, if it doesn't take that and it just left, right? Then because these are all the bigs. Well, in fact, they'd be a 1, 2, smalls. They'd be a 1, 2, 3 triple. Which doesn't work. So it would. Yeah, and that breaks as well. So this is definitely green. And that is probably a very unhelpful deduction. Yeah. Can't see that really doing anything. That being green like that. Makes that a 3 with an 8, 9. Three with an 8, 9. Oh, that could be a 4 if it really wanted to. Or put 1, 1, 8, 9, 8. Interesting. Tricky, but interesting. Is it most a 6? Probably can't be a 1. Well, actually, it might be able to be a 1. I did something like that, I don't know. Now, I've said you have to take one of these, don't you? Because otherwise that sums to 9, yeah. Maybe I need to think. I mean, that cell's always green, isn't it? That's a useful one. And if it goes like that. No, because I think. Yeah, so I'm saying this can't ever be 6. Because that would break. Yeah. So either you have your little party like this. Oh, is it small digits along here? Where's a 4 going? A 4 goes there. A couple of 9s. That's problematic because these two have to be the same. So if we are like this, we're then asking the question, what are all these lows? This one has to be 4, but those two have to be the same. So we definitely travel up here. We don't take that. We don't come round here at all. Circle. Certainly take quite a bit. Now these two cells are the same, of course. That'd be 6. No, because that makes those both have to be 1s. That's pretty. So now if you are the case that that's green, that would have to be 6, 1, 2. And if it's not green, then those just sum to 9. Interesting. Taking another cell here. In fact, we've 1, 2, 3, 4. We've got at least 5 in here. I'll see. Oh yeah, these two. I'm sure I thought more stuff could see that. It certainly does. This little circle now, this guy either takes 2 or 3. If he went like that, is that a problem? You get a 1, 2, 3 triple. So then you'd have to go like this. Don't really see anything wrong with that at all. Keep an eye on 5s. Probably not. Yeah, I was just looking at this circle, right? So he takes exactly 2 or 3. Then that's 4, 5. So out of all that, I think this takes exactly 3. Yeah, there's no way that's taking 4, and there's no way that's taking 2 of them. So that takes exactly 3, 4, 5. So that's either a 6 or 7. And I thought that I'd worked out, yeah, so if that does that, I said this is 6, 1, 2. This would have to be 7. So if that does that, it has to go like this. Is there something wrong with that? Yes, where are 4s? Right. So this definitely comes down like that. That's a 2. That's not 4. These two sum to 9. These two sum to 9. I still don't really know if that's going which way. I mean, if that's a 6, then that looks like that works, okay. Nice. Very good. These two cells, they go in somewhere there. I feel like it's unlikely now that these are both 3s. It could be, actually, couldn't it? Just make that pink. And I don't, and like that cell's the 3, but that's whatever, really, isn't it? 1, 2, 3, 4, 5, 6. So yeah, 6 or 7 still here. Cool. And then next up. So if you did take that, that would be a 1, 3 pair. Making that an 8. Yeah, so if you did take that, that would have to be a 3, because you'd get 8s and 1s. And 1s, and that breaks this. So that's definitely like that, and the loop comes down. Nice. 4s and 5s worth pencil marking. Rob's not. That's a 7 though. Which, yeah, it takes 2s out of this. 2s are definitely here now. Got this weird interactions going on. 1 3 pair. Is it worth doing that sort of thing? Maybe that's not 6 or 7, of course. So if this was 6, it would put a pair of 1s there. That seems okay. This could be a 1 still, actually, couldn't it? But, like, obviously it can't be a 1, but I think it can. So if yellow was 3, then you get some 8 9 pairs. If yellow's 1, then you get some 8 9. Yeah, that cell can't be 3. So 3 is definitely here or here. 3 with an 8 9 3 breaks because it puts a 6 there. So yellow is a 3, and you do get 6s and 1s and 2s. Which, yeah, I mean, whoopsie daisy. Does some stuff, doesn't it? Which is good. Right, let's think about clues that I have used now, maybe. I know that either those two sum to 3, which works with 2 and 1. And that would be 3. That would be 3 with an 8 9 going across. So that is definitely pink. So my spit it out. What are you trying to say? My initial incorrect assumption is correct, but that's not actually that useful. So this is 5 or 6. Yeah, that's true. And down here, maybe 2, 4, 5, 7. Lovely jubbly. 5's being here, is that interesting? Maybe? Maybe not. This comes up, it has to be a 1. If it goes that way, then it's chilling, I think. I was about to be like, obviously that's not a 4. So it would have to take a 2, either which way round it goes. Because the 1 3s are already there. One of those two is a 2, which takes 2s out of here and here. That's helpful. Not particularly, that's a 3 though. Is here. Right. I think we're going to want to think about this 27 now, aren't we? Because you've got this 3, and then what's small? You got some small options, and you got some big numbers. Yeah. So if you tried to come up, if you tried to turn up like this, then you're getting at most 1 orange, which an orange is big. And that doesn't work at all. So that's definitely pink, and that's green. Similarly, if you try to then come up, 2 4, not 4. If you try to come up again, you still can only get 1 orange, which isn't enough. So you definitely take this cell. See daisy. Even if you didn't take all 3 oranges, surely that's not going to be enough, is it? 17, 20. Geez, it would work with like a 3 4. That's cool. I hope that's how that works. That would be pretty. Right. 1s. Quite. That cell would be 1 or... Yeah, so if it takes that cell, then that's a 1 or 2. It's got to come up. And that would be a 4 in that break, so it definitely doesn't take that. Oops. Green, pink, 2, 3, 4. So now it can't take all oranges. Yes, because that was the only way it took all oranges. And that breaks because the whole threes that block everything. So you are definitely 3 with a 4. So yeah, so you can't take that. That doesn't work. That's got to be a 9. The 4's turning into a 9 afterwards. One way or the other. Gonna find you. 8s and 9s. 9s and 8s, because they're different, of course. 8s. 8s. 9s? Not quite. They're starting to be useful, aren't they? Cool. Lovely, jovely. So 4s are up here. Doesn't really look in as much as I thought it was gonna. Going to. That could still be 7 or 9. Alrighty. What do we need to do? This cell. That cell now is a 5. It's 5 here. That's not a 3, but yep. Well done. 4, 7, 9 leaves 1, 2, 6, and 8. More cells than I thought. So if that turns up, that would have to be an 8 with another 1, 2. Which gives you a 6 here. Seems okay. That would have to be the 1. Yeah, I can't really see anything wrong with that. This circle is going to be helpful. Because we definitely got 3 from here. Whichever way that turns, and that means that has to be green. Which makes this a 2. Makes this a 7. What else does that do? Not very much. This cell's pink, obviously. So if you try to go around the outside, then I think that's okay. Interesting. Very interesting. 7, 8, 9, 2, 3, 5. This cell is now a 6. God, that's got to give us something. Surely. 1s and 2s. Is it going to be things? Oh, yeah, no, so we know there's a 2 there or there. Doesn't really say very much. But do need to be aware about things in these cells not repeating. Something to be careful of, isn't it? So if we did turn up, we'd be 1. In fact, if we did turn up, you do then have to go out and around like that. Which 4, 9, 1, 2, 3, 7, 1. Those would have to be a 7, 8 pair. 1, 2 in the middle. Yeah, no, that all seems like that works. But 7, 8 pair with a 2 there. I can't see anything wrong with that at all. So what happens if you come... What happens if you turn like that? Then obviously you just finish nice and easy with the 1 here. So if that, then you go 4, 9, 1. And that seems like not a problem. And if you come like this, then you've got a couple of options. You definitely go around to there. That would be a 9, a 7, 8 always. 9, 7, 8 always. I think you would be allowed to come down. I suppose one of those would always be a 1 and you'd always get a 2 there. that the point? I think I'm missing something. 2, 3, 4, 6, 7, 9, 1, 8. That's a single 5. 1, 8, 3. I promise I don't have a cheat thing open to see that one was 1 digit. There's a 4 which I should have seen. So 2, 7 pair, 1, 4, 6. 4's more useful than I thought. See, those two can't be the same. A 2 somewhere here or here, but that doesn't matter with which way round that wants to go. Fours across there. So I even pencil mark those ones in. I thought I won't bother. Thought actually probably is going to be useful, isn't it? Almost something there. 5 6s, not quite. 3 7s, 4s, 4s there. I mean, 4s up and down here. Why have they got 2 places? Far too many options to them, isn't it? 2 7 1 6. Yeah, so this cell can't be 1 or 6 because then that would have to repeat looking at here. So that's definitely an 8. Which tells you nothing. Yeah, no, it does. You get a 3, 3, 8, 9 triple. 1, 2, 4, 7. Ones are there. Ones are here. 2, 4, 7. It's a special digit 6. Not really doing anything. Yeah, it'd be nice if like that was a 6. Get some stuff forced around, but I can't see it doing that. Like, not necessarily. I was just thinking about 2. So if that were 2, you get the 7, 4, 6 at the bottom of that column. See, that would be a 2, 7 pair. I can't see anything wrong with that. All right, let's think about these options again. You either go 9, 4, 9, 1, and immediately connect up. And that does some things like force that to be a 2. You'd get a 1, 2 pair. 1, 2, 7, 2. 2's there now. That would be a 7. 7's here. Can't see anything wrong with that. Or if you turn like this, whoops. If you turn like this, then you go 4, 9. That would have to be a 7, 8 pair at the top. Yes. Okay, this breaks. Cool. So if you come up and around like this, you get your 4, 9. This would have to be a 7, 8 pair with a 1 or a 2 in the middle. But looking along, if that's a 7, 8 pair, that's a 2, that would be a 1. Yes, this would be a 1 in the middle. So we can't turn to here to finish off, and we can't turn to here because that would be a 5 or 6. So we do go up like this, which is nice. It gives you all of that. Let's get rid of this. Let's finish off our little line here now. Let's just going to clear that. 1, 5, 6, 7. 1, 2 pair leaves 4, 6, 7, 9. 4, 9. 9, 4. Close. 1s. 9s. I thought this was going to do it all. Seven, 2. Yes, I remember that now. So this has got to be the green to finish off the loop. Lovely. 2, 5, 6. Come on, there's got to be a pod somewhere, isn't there? How's that not sorted? 8s, 9s, 1, 3, 5s, 2s, 4s, 2s because of that. It's not 5. 5s are here. 6, 7, and 8. 7s. That's not 7. Yes, it's flooding back now. 7s and 7, 6s here. There's a 6. Gives you a 6 there. 4, 9, 4, 9. It looks like we've broken the back of it. 9s, 9s there. And I've got 2 7s in the box. They were even right next to each other. How on earth did I do that? I said that's got to be a 7. That was just a 6 anyway. Well, that's undone some of that hard work, isn't it? Sorry. I was going to start off so well with this. I was going to nail every puzzle, not make a single mistake. Yeah, that goes, though, didn't you? 2, 5, 6, 3, 5, 8. 7s is 1, 5, 6 triple. Don't have to worry about repeats there, nor here. It should only be Sudoku because I've placed everything on the line, placed all the clues that affect the line, and I think this was the only, and that of course was the only cage I needed to be wary of repeats on. I think I'm just not seeing something. 8s, 8s, 9s. 4, 9, 7 here. That's 6, 6. 1s at the top. 6, 1, 5. 6, 6, 6. 1, 8. Obviously, that's not a 6. 3, 8, 9 triple. Golly. Yeah. I did better when I assumed that that was a 7, didn't I? Try that again. Maybe not. Have I used all the clues? Like, I've written in all my circle digits. That all seems okay. What's along here? Yes, there's a 4, 9 pair. Yeah, I should have looked at this because that was when I saw what I'd done. Where that had gone wrong, hadn't I? 3, 8, 7, 3, 8, 7, 5s, 5s. 2, 6, 7, 6, 4, 2. 1, 4 looks like a 7. Use your words. 4, 9, 4, 9. 3s and 6s. Leave a... What's that? Sell a 5? Looks like a 5. Good. And then... That's still holding out 1, 6, except I don't think it is. I think it's just me not seeing things. 6 and 1. 4, 5. Let's get rid of a 6 from them. Let's leave a 2 and a 7 for fun. 9's up here. 5, 4, 4, 1, 1, 8. 8, 3, 9, 3, 8, 3, 6. Awesome. Very good. Well, sorry about me poo-pooing it at the start where I was like, oh, this doesn't use the flock of pixels rules. If I'd actually bothered to read them, then I wouldn't have had any of that discrepancy. Yeah, very cool combination of the rules. It was nice to solve the one See if I can bring up the name of it easily. Nope, apparently I can't. Oh, I've meant. Oh no, I haven't. Yeah. Oh, I have multiverse. There we go. The rules of multiverse and yeah, using the orthogonal stuff off block of pixels was very good. Had a clean solve. I like the design as well, I have to say. That was nice with the symmetrical pattern. That felt quite symmetrical, multi-universe, university. Yeah. Yeah. All smooth. Nothing like crazily difficult. I'd be interested if this sort of stuff I was doing was as intended. Some of that was a little bit long in terms of the deduction length chain thingamajiggy, but not too much at all. Like it was all doing your headable sort of thing. So yeah, I don't think much else I want to say. Definitely a strong first puzzle. But yeah, thank you very much for the puzzle. Hope you enjoyed watching. Chat to you all sometime later. Thanks.